Alright, so if you missed that, a prompt came up to install the most recent version of WSL, Windows Subsystem for Linux, when I restarted my computer. And you see now that when I go into Windows features, this Subsystem for Linux is an active feature. So is Virtual Machine Platform. Now, I did not turn these on myself. Docker turned these on during the installation, so that's a good sign. If I go into the terminal, use probably any terminal, but I'm just going to use PowerShell since we're dealing with Windows stuff here, and say WSL version, perhaps. It says Windows Subsystem for Linux must be updated to proceed. So this is the prompt that I was getting when I restarted the computer, and I'm going to hit any key and hit yes, and it's downloading the Subsystem for Linux. So again, I mentioned this in the previous video, but the Subsystem for Linux is just a way to run essentially like a Linux kernel or the Linux operating system inside of Windows. And that is pretty essential for running Linux type containers through Docker. So Docker will let you run containers that have Windows inside of them, and it'll also let you run containers with Linux inside of them, which is what most people are going to be using, is the Linux side. So it's very important that you have this building block upon which Docker can use your operating system in the ways it needs to. And now we're getting that version, WSL version 2.3.26. We're happy to see this 2 at the beginning because that means we have WSL version 2. So let's see what happens when we open Docker Desktop. Now Docker will be a program that is installed and accessible on the command line of your various terminals. It'll be added to your path and such, but a lot of the functionality isn't going to happen until you open Docker Desktop, or you can also set up Docker to sort of automatically start in the background and run on your computer. And if you look at this little taskbar widget, you see that Docker Desktop is stopped. It seems like it's trying to start itself. Maybe if we quit it and reopen, maybe we will get it to open for us. It could just take a long time, especially since it's the first time after installing. Okay, so here we go. We have to accept these terms. There's no option, I believe. It's essentially saying that if you're going to use Docker for commercial purposes, you can't just use it super freely. There are limitations without paying Docker, with exceptions for small companies. So I'm just going to skip logging in. That's not necessary at all for using containers that are Alright, so now it looks like Docker is running. So that's good, that's what we want. I'm going to check in settings to see how Docker is actually running on this computer. So I can see that if I click on resources, you're using the WSL2 backend. So resource limits are managed by Windows. And so this is what we want. This means that the back end of Docker is using WSL, just like I mentioned. And now, if I open a terminal, the Docker program should be installed, and I should be able to run Docker PS which stands for Docker processes, and this is listing, this is a table header with no items in the table, listing all the containers that are running now, which is none. If I say Docker images, I can list any of the images that are on my computer, which are also none. So if we go back here, how do I run a container? Or there should be sort of a getting started. Let's see, I'm going to go to images and search images to run, and I want to run the hello world. Yep, so this is the official Docker hello world. So you can pull that or you can run it. I'm going to show you how to do things in the terminal, because that way if you install the headless version on Linux, you're still going to understand what's going on. So I'm going to say Docker pull. Because it's official, this is the name of it. You don't need any organization before hello world. Docker pull hello world. It's going to use the tag latest, so that would have been the same as hello world : latest. This is called a tag, and it's pulled that latest image, and then Docker run hello world. Oops, hello dash world. Hello from Docker. So this shows that you've made your installation correctly, and that's what we're looking for. And so if you were to install other WSL operating systems such as Ubuntu or Debian or something like that, I believe you can make it so that Docker will share this installation even though you're on sort of a different operating system. I think it's possible to connect those Dockers, but I'm just going to show you running purely on Windows but with the bash terminal. See, you also have access to Docker because it's on your path, because it was installed. And if I do Docker ps-a, that stands for all, I can see this hello world container that exited 50 seconds ago. So it wasn't showing me that as a running container because it had exited, but it was showing that it had run. And you see there's a container ID. You can use that to kind of reference containers. Like, for example, I believe you can Docker remove and then put the container ID. Can't seem to type here with the control insert and the shift insert. Docker rm shift insert. There we go, and it gives back that ID. And so if we do Docker ps-a, you can see that that container has been deleted. Even as it's exited, it's now deleted. So you could do a lot of these things in Docker Desktop as well. Sometimes Docker Desktop can be useful to do things a little bit more simply, but I would recommend, if you can, try to learn the terminal commands for Docker, because those are going to be more standard across different installations of Docker you may use. You may not always have that GUI, that graphical user interface, available, and you may just want to do things on the terminal. So you're always going to be able to use the terminal version of things, and that way you have one kind of skill set that will apply anywhere you want to use Docker. So just a quick overview, what happened when we ran the hello world container. It started it did what it had to do, it printed out to our terminal, and it exited because that was the design of the container. Now other containers, they have a design to start up and stay open until you close them. For example, you might start up a web server like Nginx, and that might serve your HTTP traffic. It might serve your HTML files to your users through a web service that you keep running. So you keep this computer on 24/7, and you connect it to the open internet, and you connect the Docker container to your host network on your computer, and then all that traffic can go from the internet to your Docker container and back. And you could run a web service out of Docker, so it doesn't have to run directly on your computer. It can run inside this little sandbox that is Docker and the Docker container. And so those images will just keep running until you close them or they fail or something like that. Whereas, like the Hello World container, that's just gonna start up, do its thing, and then exit. And that's why it wasn't running. Whereas if we had started a different kind of container, that one might stay running. For example, we could see what would happen if we look at, maybe we try like Docker. Let's see if I can do this on the first try. Docker pull Nginx Alpine. Alpine is like a small version of Linux, so it should be relatively small. This container, be quick to pull, and then Docker run Nginx Alpine. So it started up, and let's see if we go to our containers in Docker Desktop, we can see that this is running actively, and there are no ports happening, nothing connected to our local host network, I don't believe. But if we look at the those same logs that we saw in the terminal, there might be a standard TCP port like port 80 or something where this would connect to. So let's see, maybe that port might be 80 or it might be 8080. So I'll say port 80:80 to connect my host network to the Docker container. I always forget the order, but there's an order there, and then in case you wanted to map it to a different port, and then I'll do 8080 as well. And this has to come before the container name. I'm going to allow Docker to access that TCP port, connect to my host network on my computer, and let's see if we can access the web server. And there we go, it was on 80. So that was the standard HTTP port, just like if you were to go to http://localhost without any colon, any port, without any colon, the assumption is port 80 for HTTP. So just go to localhost and you'll see that server is there. But then if I were to Control-C to stop that container, because I had run that directly attached to my terminal. I could have also run that in the background with -d detached, so that would run it, just give me the ID, and then keep that running in the background. So if I did Docker ps, I would see that it's up 8 seconds, created 8 seconds ago, and I'm still gonna have access to this here. But then if I Docker here, so I can refer to this by its name, which I can give it a name, or I can also refer to it by its ID. So I'm going to Docker stop that ID. Should give me back that ID if it successfully stops it. Yep, it gave me that ID back. And then Docker ps, you should see it stopped. And if I reload this page, the web server is now down on localhost, so the site can't be reached. So there's two different types of containers, really easy to get started with. Nginx has some preloaded HTML that it's going to serve on port 80 so that you can just test things. But you could also put your own HTML files in there, and you could see how you could really easily use Docker to get a web service up and running, and you don't have to run any of that directly on your computer. Just run it inside that Docker container, and then you hook up the network to your own network, and you're good to go. So that's going to conclude this video on setting up Docker. Thanks for watching.